Well, here we are testing claims again, claims about proportions. Don't worry, this section is going to be much faster and easier than section 8.2. So just as a recap, for binomial situations, or in other words, proportions, we're going to have the following. N is the sample size, X is the number of successes out of those N subjects. When you divide those two numbers, that's the sample percentage, p hat, sample proportion. The claims are going to be about p, which means the proportion for the whole population. So the formula for the test statistic, and right here I put TS because sometimes I like to abbreviate it rather than type out or write out test statistic so often. Anyway, here's the formula, where the P and the Q right here, they come from the claim. P comes from the claim, Q is 1 minus P, and this is the P hat right here. But if you don't want to use the formula, you don't have to. We're going to be using the graphing calculator for that. And since this is about proportions, then critical values will be in the table A2. Okay, we're going to have two examples. The first one. So with debates about U.S. immigration policy, some people that want to close the borders say, well, undocumented immigrants use emergency rooms and then they don't pay their bill, so these people are complaining about that. Well, let's see what the statistics say. Do the undocumented immigrants use emergency room more than other people? So what I found from the Center of Disease Control is in 2011, 20% of adults in the U.S. visited emergency room. And elsewhere, I found a survey of 8,240 undocumented immigrants. 815 had been to an emergency room in the last year. So let's see how these compare. We're going to use 95% level of confidence to test the claim that the undocumented immigrants visit emergency rooms at the same rate as everyone else. So we're going to test the claim that P is 20%. So that would mean H1 has a not equals, so this is going to be a two-tails situation. We're using 95% level of confidence, so alpha equals 0.05. And then here's the sample evidence, and I went ahead and divided them. This is supposed to say P hat is equal to this. So this is 9.9%, way less than everybody else, about half as much. So when you go and look at critical values, since this is two-tailed, you could look at the bottom right corner of table A2 and it's got these common values. So when using 95% level of confidence, if it's two tails, you can't use this when it's one tail, but when it's two tails, then it's going to be 1.96. So here's my little graph. So next, we're going to use the calculator. So you go to Stat, move over to Test, and this is one proportion. Next, type in the information. So this is the 20% that comes from the claim, or is also found in H sub O. And then you put in the sample data, and this should say not equals, just like the H1. And this part right here is actually so that it knows which, if it's right tail, left tail, or two-tailed. That way it calculates the p-value correctly. And then hit enter and you find out that the test statistic is negative 22.941. Moreover, the p-value is practically 0. It's not exactly 0, but for these three decimal places it's 0. So that means that there's a very, very, very small chance we would be wrong if we reject H sub O. Or the other way to look at it is, if the test statistic is negative 22, does it go past negative 1.96? And the answer is way, way past. So we definitely proved something. So we start by saying reject H sub O, which means we're rejecting this equal sign. It is not equal to 20%. It's more like about 10% for undocumented immigrants. That means that the claim that said it was going to be 20% is wrong. Ta-da! We proved something. All right, let's try to prove something else. So if you look at those people that major in science and engineering, and they actually graduate, not just say they're going to do it, but they actually graduate, I test the claim that less than 40% are female. So I was going to say less than 50%, as if it was 50-50, but I already know that it's going to be more like 30 or 40% are female. Okay, then I found these statistics. In 2010, in the United States, there was a total of 360,851 people that graduated in science and engineering. So that would be all private and public universities. 125,092 were female. So the claim is that it's less than 40%. So H1 stays the same, pointing to the left, so it's a left-tailed test. That means all of this 0.05 is going to be in the left tail. Next, here's the sample data. This is supposed to say p hat. I can fix that. And then it is more like 34.7%. That's definitely less than 40%. So we may be able to prove something here. Let's see. So here's the table. And this one is a left tail, 0.05 in the left tail. So that means you have to look through the table and find 0.05. Well, I believe this is the first time that we ran across this in this class. Right here, there's a tie between this one and this one. This little star says if you were looking for those and you want 0.05, then you should use negative 1.645. So there it is, left tail, negative 1.645. Now, calculator time. So again, stats, test, 1 prop z-test. Type in the data, the 0.4. Technically, this part right here is saying look at h sub o, and the p is what? 0.40. And then this should be pointed to the left. Hit enter, and we find out that the z is negative 65.407. That is out of the ballpark. So, with a test statistic of negative 65, does that go past negative 1.6? Yes, by a lot. So, reject the claim this time, reject h sub o. This time the claim is true because this is what we reject. So we're rejecting, does it equal 40%? No. It's actually more like 34.7%. The claim said it was going to be smaller than 40%, so that means it's true. Also, look at, the claim is pointing to the left. I claim that it's going to be to the left of 0.40. This, sorry about that, I hit the wrong button. I was saying this, negative 65, is way to the left. So in a way, it's supporting what this said was going to happen. It goes to the left. Or you could just look at this and say, well, they said it's going to be under 40%. It's 34%. So yes, this is enough evidence to prove that it's true. In fact, it's a lot of evidence. All right, see you in the next section where we're going to test claims about means.